Hi, hello. So, our next video is about the types of redox reaction. This is the fourth part of the video. Okay, so let's start. Types of redox reactions. First one, combination reactions. As we know, combination reaction is a reaction in which two or more reactants combines to form a single product. Two or more reactants combines to form a single product is known as combination reaction. Clear? So A and B or both A and B must be in the elemental form for such a reactions to be a redox reaction. Either A and B or both A and B. Okay, must be in the elemental form like this. Then only such a reaction can be a redox reaction. All combustion reactions which make use of elemental dioxygen as well as other reactions involving elements other than dioxygen are redox reaction. See here, carbon plus oxygen gives carbon dioxide is a redox reaction, and reactions involving elements other than dioxygen. See here, nitrogen. Burning of magnesium in the presence of nitrogen will give magnesium nitride. Then burning of natural gas, that is methane, will give us carbon dioxide and water. So, redox reaction first case is combination reaction. These are example for combination reaction. Okay. Now, see this one is also given as a redox reaction. This one also given as a redox reaction, but here two products are formed. Then, next one is decomposition reaction. It is just opposite to that of combination reaction. We know that a single reactant will splits up to two or more products. Single reactant splits up to form two or more product. Such reaction is called redox. Such reaction is called decomposition reaction, and uh, that type of decomposition reaction can be named as redox reaction also. Okay. See, a decomposition reaction leads to the breakdown of a compound into two or more components, at least one of which must be in the elemental state. See, when such a decomposition reaction, when it will be a redox reaction, whenever that compound is broken down, it breaks down to form two or more components, and in that components, at least one of which that should be in the elemental state. അപ്പോൾ ഒരു സിംഗിൾ റിയാക്ടർ സ്പ്ലിറ്റ് ആയി ടു ഓർ മോർ പ്രോഡക്ട്സ് ആകുമ്പോൾ അതിൽ പ്രോഡക്റ്റിൽ അറ്റ്ലീസ്റ്റ് വൺ ഓഫ് ദ പ്രോഡക്റ്റ് ഷുഡ് ബി ഇൻ ദ എലമെൻ്റൽ ഫോം. So in this case, water H2O splits up to form hydrogen and oxygen as a decomposition and also can be considered as redox reaction. Then sodium hydride splits up to form sodium and hydrogen. Potassium chloride is splits up to form potassium chloride and oxygen. It may carefully be noted that there is no change in the oxidation number of hydrogen in methane under combination reaction, and that of potassium in potassium chloride in reaction 7.28. See, in this case, hydrogen order oxidation state plus 1 in the reactant and product also plus 1. Similarly, in the case of potassium chloride splits up to form potassium chloride and oxygen where the valency of chlorine is same. Where the valency of chlorine is same. Clear? So, it may be noted that this must may also be noted that all decomposition reactions are not redox reaction. Okay. See, we cannot consider all decomposition reaction as a redox reaction. Okay. എല്ലാ decomposition reaction റിഡോക്സ് റിയാക്ഷൻ ആകാത് ഏന്നാ അതോടെ പ്രോഡക്റ്റിൽ അറ്റ്ലീസ്റ്റ് വൺ എലമെന്റൽ ഫോം ഷുഡ് ബി ദർ ഒരു ப்ராடக்ட் ஷுட் பி இந்த எலமெண்டல் ஃபார்ம். ஸோ இதிலெல்லாம் எலமெண்டல் ஃபார்மில் தான் இருக்குது. ஸோ ஹைட்ரஜன் ஆக்சிஜன் சோடியம் ஹைட்ரஜன் அந்த மாதிரி. ஓகே, ஆனால் சி இன் திஸ் டைப் decomposition of calcium carbonate that become calcium oxide and carbon dioxide. Here, this is not a redox reaction. Decomposition of calcium carbonate is not a redox reaction. Clear? It's not a redox reaction. Now, another type of redox reaction is displacement reaction. We know that a more reactive metal or element is replacing a less reactive element or a metal from its compound. That is displacement reaction. In a displacement reaction, an ion in a compound is replaced by an ion of another element. X plus YZ gives XZ plus Y. X is actually replace that Y from that compound. Displacement reactions fit into two categories: metal displacement and non-metal displacement. Clear? Metal displacement and non-metal displacement. For displacement reaction, always is not metal. Metal displacement mattulla, non-metal displacement will be also there. Now, first case, metal displacement. In that, a metal in a compound can be displaced by another metal in the uncombined state. A metal in a compound can be displaced by another metal in the uncombined state. Okay, we have already discussed about this in the class of reaction 7.2.1. Nam different reactions discuss பண்ணிருக்கோம். Type of reactions. Okay, now metal displacement reactions, it find many application in metallurgical processes in which pure metals are obtained from their compound in ores. See, we know that ores, from ores we can separate metals, and that process are called extraction of metals, and there involves various reactions, and one of the main reaction that can be used to separate the metal from its ore is by displacement reaction. அதுக்கு ஒரு மோர் ரியாக்டிவ் மெட்டலை அதோட ரியாக்ட் பண்ணும்போது இந்த லெஸ் ரியாக்டிவ் மெட்டலை ரீப்ளேஸ் பண்ணிட்டு ஃப்ரீயாக விடும். ஸோ அந்த ஃப்ரீயாக விடுற எலமெண்ட்ஸை நமக்கு எக்ஸ்ட்ராக்ட் பண்ணுற மாதிரி இருக்கும். ஸோ எக்ஸ்ட்ராக்ஷன் ஆஃப் மெட்டலுக்கு டிஸ்பிளேஸ்மெண்ட் ரியாக்ஷன் பொருத்தமானது. ஸோ காப்பர் சல்ஃபேட் ப்ளஸ் சிங்க். இங்கே காப்பரோட oxidation state plus 2, sulfur is plus 6, and oxygen is minus 2. Zinc oxidation state elemental stage இருந்தனால 0. Then copper also 0. Then zinc sulfate is plus 2, plus 6, minus 2 respectively. Then V2O5 calcium react பண்ணும்போது V and calcium oxide. Okay, here plus 5 is changed to 0, and calcium 0 changed to plus 2. Here calcium is replacing vanadium from its compound. Then magnesium is the reducing agent. It is replacing, okay, titanium from its compound. This is also a displacement and also a redox reaction. Aluminium is replacing chromium from its oxide. So all these are example for metal displacement, and that can be considered as a redox reaction. In each case, reducing metal is a better reducing agent than the one that is being reduced. So magnesium is a better reducing agent than titanium. Aluminium is a better reducing agent than chromium. And the madri, a more reactive metal is acting as a strong reducing agent, and this reducing agent gets oxidized. Okay, which evidently show more capability to lose electron as compared to the one that is reduced. Next one is displacement reaction. Another classification, that is non-metal displacement. The non-metal displacement redox reactions include hydrogen displacement and a rarely occurring reaction involving oxygen displacement. See, non-displacement redox reaction, most of the time it include the hydrogen displacement, and in some cases oxygen displacement. Okay, here all alkali metals, that is group 1 metal, and some alkaline earth metal like calcium, strontium, barium, they belongs to group 2, which are very good reductants. Okay, they have a strong tendency to reduce others. So it will displace hydrogen from cold water. So sodium, calcium, all these react with the water and replacing hydrogen from that water. and it's become sodium hydroxide, and in the second case calcium hydroxide, and hydrogen is released. So this can be considered as a redox reaction, okay, where non-metal displacement is taken place. Next one, less active metals such as magnesium and iron reacts with the steam. Okay, steam. Here more reactive metals will react with the cold water, from cold water. But magnesium, iron, they reacts with the steam to produce dihydrogen gas. Okay. So Mg plus H2O, Fe plus H2O will give you magnesium hydroxide in the case of magnesium and iron oxide in the case of iron, and hydrogen is released. Many metals, including which do not react with cold water, are capable of displacing hydrogen from acids. Okay, many metals, including those which do not react with cold water, are capable of displacing hydrogen from acids. Dihydrogen from acid may even be produced by such metals which do not react with the steam. Cadmium, tin are examples of such metals. See, dihydrogen from acids may even be produced by such metals which do not react with the steam. Examples are cadmium and tin. A few examples for displacement of hydrogen from acids are ഇപ്പോൾ ഇതെല്ലാം വാട്ടർ ഇനി ഹൈഡ്രജനോടെ സിങ്ക് പ്ലസ് ഹൈഡ്രോക്ലോറിക് ആസിഡ് സിങ്ക് ക്ലോറൈഡ് ആൻഡ് ഹൈഡ്രജൻ magnesium plus hydrochloric acid magnesium chloride and hydrogen iron plus hydrogen chloride ferric chloride iron chloride and hydrogen ferrous chloride, okay, iron chloride and hydrogen. Okay, here dihydrogen, see this one, these three reactions are used for preparing dihydrogen gas in the laboratory. The reactivity of metals is reflected in the rate of hydrogen gas evolution, which is the slowest for the least active metal iron and fastest for the most active metal magnesium. இப்போ ஹைட்ரஜனோட அமௌண்ட் ப்ரொடியூஸ் பண்ணுறது வச்சு which is more reactive, which is least reactive னு பார்த்துக்கலாம். Iron is the least reactive, so less amount of hydrogen is produced, and the fastest for most reactive metal is magnesium. Okay, magnesium compared to other two and produce large amount of hydrogen gas. Okay, then very less reactive metals which may occur in the native state such as silver and gold do not react even with the hydrochloric acid. So very less active metals which may occur in the native state such as silver and gold do not react even with the hydrochloric acid. So very less reactive metal, they do not react with the hydrogen in hydrochloric acid. Next, zinc, copper and silver, they through their tendency to lose electrons, showing their reducing activity in the order zinc is greater than copper is greater than silver. Okay, based on their electron losing tendency we can arrange them in the order of their reactivity. That is, zinc is more reactive than copper and it is more reactive than silver. Clear? Next, like metals, activity series also exist for halogens. Halogens 17th group elements ആണ് fluorine, chlorine, bromine, iodine. அதுக்கும் என்ன activity series இருக்கு. The power of these elements as oxidizing agents decreases as we move down from fluorine to iodine in group 17 of the periodic table. See, there also halogenukum oxidizing tendency based ആയി ഒരു ടേബിൾ இருக்கு. அதில் ஃப்ளோரின் தொட்டு கீழே வேறு அயோடின் வர டவுன் டு த குரூப் போகும்போது ஆக்சிடைசிங் ஏஜென்ட்டோட பவர் வந்து டிக்ரீஸ் பண்ணும். திஸ் இம்ப்ளைஸ் தட் ஃப்ளூரின் இஸ் ஸோ ரியாக்டிவ் தட் இட் கேன் ரீப்ளேஸ் குளோரைட். அதனால என்ன அர்த்தம், ஃப்ளோரினுக்கு குளோரினை ரீப்ளேஸ் பண்ணலாம், தென் ப்ரோமைடுனையும் அயோடைடையும் எல்லாம் ரீப்ளேஸ் பண்ணிக்கலாம். ஸோ ஃப்ளோரின் இஸ் ஸோ ரியாக்டிவ் that it attacks water and displaces oxygen of water. So fluorine can displace chlorine, bromine, iodine, and fluorine can also displaces the oxygen of water. See, H2O plus F2 gives HF plus O2. So it is for this reason that displacement reactions of chlorine, bromine, iodine using fluorine are not generally carried out in aqueous solution. On the other hand, chlorine can displace bromide and iodide ions in the aqueous solution as shown below. See, in the type fluorine chlorine what is that bromineயும் அயோடைடையும் ரீப்ளேஸ் பண்ணுறதுக்கு அது அக்வஸ் சொல்யூஷனில் இல்லை மோஸ்ட் ஆஃப் த டைம் நடக்குது. அப்போது இங்கே வந்து அக்வஸ் சொல்யூஷன் யார் குளோரினுக்கு ப்ரோமைடை ரீப்ளேஸ் பண்ணுறது ப்ரோமைடையும் அயோடைடையும் ரீப்ளேஸ் பண்ண முடியாது வந்து அக்வஸ் சொல்யூஷன் ஃபார்மேட்டில் தான் டிஸ்பிளேஸ் ஆகுது. ஓகே, Cl2 plus KBr gives KCl plus Br2. Cl2 plus Ki gives KCl plus I2. As bromine and iodine are colored and dissolved CCl4 can easily be identified from the color of the solution. ப்ரோமினுக்கும் அயடினுக்கும் சிசிஎல்4 ரியாக்ட் பண்ணும்போது அதில் இருந்து அதோட கலர் சேஞ்ச் ஆகும். ப்ரோமினோடைய அயடைடையும் கலர் சேஞ்ச் ஆகும். அதனால் அதை ஒப்சர்வ் பண்ணிக்கலாம். ஸோ equation Cl2 plus 2Br minus 2Br minus bromide ion will give you 2 chloride ion plus bromine. Then chlorine plus 2 iodide ion gives 2 chloride ion plus iodine. In this reaction, these two reaction form basis of identifying bromide and iodide in the laboratory through the test popularly known as layers test. Okay, these two are for the identification of bromide and iodide ion, and that process is called layer test. It may not be out of place to mention here that bromine likewise can displace iodide in a solution. So fluorineக்கு chlorineயும் bromineயும் iodideயும் displace பண்ணிக்கலாம், chlorineக்கு bromineயும் iodideயும் displace பண்ணிக்கலாம், and bromineக்கு iodide ionையும் displace பண்ணிக்கலாம். So down to the group, their decreasing nature, so they are reducing, oxidizing age, nature is decreases. So bromine plus 2 iodide ion will give you 2 bromide ion and iodine. The halogen displacement reactions have a direct industrial application. The recovery of halogens from their halides. See, this is halide, and recovery of halogen from their halides requires an oxidation process. So this reaction is known as oxidation. Okay, getting, what is that, recovering halogens X2 from their halides 2X minus halide இருந்து halogen separate the process நாம் அதுலேயும் இருக்கிறது oxidation process. Okay, then the X denotes a halogen element, whereas chemical means are available to oxidize Cl minus, Br minus and I minus, as fluorine is the oxidizing agent. There is no way to convert fluoride ion into fluorine by chemical means. The only way to achieve fluorine from fluoride ion is to oxidize it electrolytically, the details of which we will learn in the later stage. See, இப்போ fluorine is the strong oxidizing agent கண்டுபிடிச்சாச்சு. So there is no way to convert fluoride ion into fluorine by chemical means. We cannot separate fluoride ion. We cannot convert fluoride ion into fluorine molecule. The only way to achieve fluorine from fluoride ion is to oxidize electrolytically அதை oxidize பண்ணணும். அப்படிதான் சொல்லியிருக்கு. So type of reactionல நம்ம combination, decomposition, displacement அதுலேயும் 2 type of displacement படித்தோம். Exercise, not all the equations are very important. அந்த equations எல்லாம் நல்லாமே go through பண்ணிக்கணும். இந்த theory பார்ட்டும் நல்லாவே read பண்ணிக்கணும். Okay, so remaining part, the remaining pages, these topics will be discussed in our next video. Okay, I hope you have understood all the points that I mentioned. Okay, இப்பவே இந்த chapter from the beginning you need to read. Okay, so see you in the next class. Thank you.